All right, let's talk about one of the most famous numbers in all of physics. It's the ultimate speed limit of our universe, right? But what if it's not really what we think it is? What if it's actually an illusion, something born from the very fabric of the cosmos itself? And there it is, 299,792,458 meters per second. We all know it as c. It's so precise, so absolute, it feels like it's just woven into reality. For more than a century, we've basically treated it as one of nature's untouchable fundamental constants. But you ever just stop and wonder why? I mean, why that exact number and not something else? Why is the universe's speed limit clocked in at this very specific value? It's one of those questions where the answer is usually just a shrug and, well, that's just how it is. But what if that's just not the right answer? Today, we're going to explore a really fascinating idea, one that says the speed of light isn't fundamental at all. Instead, it's what's called an emergent property, a consequence of something much, much deeper. So, to really get this, we're going to have to look at the cosmic speed limit through a totally new lens. And that new lens, it's called the Harmonic Scale Framework, or HSF for short. And believe me, it's a model that completely reimagines the very foundation of our universe. You see, the core idea of HSF is that the universe isn't just empty space with little bits of matter dotted around. No, instead it's a dynamic, layered system that's made up entirely of waves. Now, this is a huge shift in how we think about things. The HSF model basically suggests that everything we see and interact with, particles, fields, the whole shebang, is just a different expression of one single total wave that's been broken down into what they call harmonic channels. And when we're trying to figure out the speed of light, this model says we only need to zoom in on two specific layers, two types of waves that are absolutely crucial to the whole story. So let's meet the two main players in this cosmic drama, a couple of waves known as K5 and K6. Okay, so on one hand, you've got K5. Think of this as a super fast timing wave that's just zipping along a kind of boundary surface of the universe. And on the other hand, you've got K6. This one is the total opposite. It's an incredibly slow background wave, like a deep hum, that sets the absolute, unchangeable clock for everything else. So you've got this really fast wave and this really, really slow wave. The magic happens when we look at how they relate to each other. It turns out their connection is what actually builds the speed of light. Let's try an analogy to make this super clear. Picture light as a surfer. This surfer is riding that really fast K5 wave. But, and here's the key, that wave itself is moving on top of a huge, deep, slow-moving ocean. That's our K6 background. So the surfer's speed, it's not really up to them. It's completely determined by the ratio between how fast their wave is moving and how slowly that deep ocean is crawling beneath it. And that is the absolute crucial point here. In this HSF model, c isn't some magical built-in number. It's just the result of dividing the properties of one wave by the properties of another. It's a ratio. And this is the core idea visually. The speed of light is simply the natural speed that pops out from the ratio of that fast K5 timing wave to the slow K6 background timing. It's not a rule, it's a structural property. And because this underlying wave structure is the same everywhere in the universe, that ratio is also the same everywhere. This is why c looks like a universal speed limit to us. It's not a rule that was imposed on the universe, it's a limit that just emerges from the system itself. Okay, right, but that brings up another question, doesn't it? What keeps this whole wave structure so stable? Well, the answer, according to HSF, actually lies in the geometry of the universe itself. So the framework proposes that the boundary where all these waves are interacting isn't a perfect sphere. It's what's called an oblate spheroid. Just think of a sphere that's been squashed down a tiny bit at the top and bottom. And this is where geometry literally tells physics what to do. The very specific shape of the universe acts as a constraint. It determines the exact patterns the fast K5 wave can form on its surface. That pattern, in turn, fixes a reference wavelength, which then sets the timing of the waves. And as we just saw, once you set the timing of the waves, you automatically set the value for c. It all connects. So, to wrap it all up, in this way of looking at things, the speed of light isn't some fundamental constant that was written into the laws of nature from the beginning. It's a consequence. It's simply the outcome of two things: the shape of the universe's boundary, and the timing of the waves that travel within it. And that leaves us with a really fascinating final thought, doesn't it? If something we thought was as solid and fundamental as the speed of light is really just an emergent property of a deeper structure, what other constants of nature might also just be cosmic illusions? What else is just waiting to be explained?